Today we're going to introduce the ideas of supply and demand. So say we had at a price of $3 a can, 60 million energy drinks can be sold per day. If the price instead was lowered to $2, then 80 million energy drinks can be sold per day. So we want to find a demand function. So see how we have it as P equals D of X equals MX plus B for the price of the energy drinks. Let's first say that this P stands for price. So the price, which will be the demand, will be a linear function. All right, so this is the scenario that we're using. Other times we may come to the price being quadratic or maybe a rational function, but in this particular case, we're starting off for the first time looking at supply and demand, so we're just going to keep two linear cost functions. But I do want you to see that the price is dependent on how many items are sold. So after we figure out what the demand function is, we'll go back and talk about the domain and the range of the function. All right, so similar to what we did before when we were looking at linear cost functions, we need to set up some equations to figure out how the price function will look. So we know from our given information that $3 is the price, so that goes on the left side, that's the P. 60 is the X, so we're going to put that over on the right side, so I have 3 equals M times 60 plus B. Hopefully you can see that we can do that a second time because we also know that when the price changed to $2, then X will be 80. All right, so this should be a similar kind of thing to what we've done before, and generally what we want to do with these two is subtract. So I'm going to subtract these two equations. 3 minus 2 is going to give me 1. And then 60 minus 80 will give me negative 20. And again, I've reversed, kind of just changed them around to put the M on the right side. And once again, the B's will cancel out. All right. If I just bring this negative 1 over 20 over to the left side, I'm dividing, and I get negative 1 over 20 is M. We'll come back to that. All right. I need to find the B. So now that I know M, I'm going to place it back into the equation. So I have 3 equals negative 1 over 20. And I put it into the first equation, obviously. My X there was 60 plus B. So 20 goes into 60 3 times. I have 3 equals negative 3 plus B. So I shift that negative 3 over to the left. It becomes positive. So now I have B is 6. So here's my demand function, demand equation, if you want to say it either way. P equals negative 1 over 20x plus 6. All right. So this is the first time we've been really talking about this demand equation, so I want to point out some things. So this 6, that's where it's going to hit the y-axis. So if I were to draw this, not a really good drawing, but up here at 6, this would be my y-intercept, and that says that nobody's buying it for $6. But if I were to decrease the price, more people will buy it. So you can see it has a negative slope. So this is not going to be accurate, this little drawing I'm just going to do, but I can see it's doing something, right? So if I decrease the price, so this is P on the y-axis, this is X on the x-axis, which is good. As the price goes down, the demand goes up. That's a normal situation, is that when price decreases, demand increases in that negative slope. So I want you to think about that. All right, part B, what's the domain of the function? Well, I kind of gave you a hint already by drawing you that little graph to say the smallest we can sell is 0, right? We can't sell negative. So you do want to think a lot of times in this class, domains will start a lot of times at 0. I don't have negative. There is no negative infinity in business calculus. As the price decreases, so it started at 6 and nobody was buying it, but as it decreased, it will continue to decrease, but it can't go past 0. So at 0, they're free. We're giving them away after that. So I'm going to set that price equal to 0. So 0 is negative 1 over 20, x plus 6. The 6 comes over, so now I have negative 6 is negative 1 over 20. And it says x is 120. So here's my domain for the demand function. The domain is somewhere between 0 and 120. It is inclusive, so I have those closed brackets. The range then deals with the price. It's the possible price points I could have. So the smallest the price can be is 0. And from the equation, the negative 1 over 20x plus 6, we see the largest price would be 6. So I go from 0 to 6. All right, so let's talk about the opposite. So the first part, this demand, we'll go back real quick and look at. Demand is the idea of consumers. What will consumers buy? How much money will they spend, right? And definitely our ideas as consumers is, hey, when you charge less, we'll buy more. That's why they offer 2 for 1, or if you buy 2, it's a cheaper price. So there's these idea they attract us by decreasing the price, offer a sale. It's going to get us to buy more, hopefully increase their revenue. On the opposite side, suppliers are also trying to make money, so they're going to limit their operations to what makes them the most money. So they need to look at how much are you willing to pay them and how much time will they spend making your product. So here's our scenario. It's at a price of $1.50 per can, 15 million energy drinks can be produced per day. If the price is increased to $2.50, then 45 million energy drinks will be produced per day. So we want to find a supply function, P equals S of X, which is MX plus B, for the price of the energy drinks. All right, so once again, we are thinking about price. So that's what the P is, but this time the S of X says we're looking at the supplier side of this whole scenario. And we're sticking to linear one more time. Again, after we know what the supply function or the supply equation is, then we'll come back and talk about the domain and range. All right. So look at what we had. We have this information about how many they'll be willing to make depending on the price that we'll sell it for. So I can come up with these equations. 150 equals M times 15 plus B, and 250 equals M times 45 plus B. Now let's talk about what's happening here. We said with demand, we're willing to buy more if it's cheaper, right? And I am an energy drink addict, which is why I do pick this one to talk about, is when I go into the store and they're 2 for $4, I buy 2. If they're 3 for $5, I buy 3. But if I just had to pay the regular price of $2.69, $2.89, whatever, I'm willing to buy more because they offer me a discount. Now think about the supplier's side. When they're making things, they're willing to make more if you pay them more money. So same thing for me. When I go to work, if they want to add another class or something for me, I want them to pay me more money for teaching that class. If you work extra at work, you want to be paid for that extra hour of work. So the idea is, if your boss offers you twice as much money to stay an extra hour, you take it. So suppliers are always going, pay me more, we'll do more. So this is the idea that when I look at demand, I expect the price to be going down. When I look at supply, I'm looking for the price to go up because suppliers are in business. They're trying to make money. They're not trying to reduce the price. They're trying to do their best to make as much money as possible. So they should feel like they're doing opposite things here. All right, so I have these equations that we set up, and one more time we will be subtracting them. That should feel normal. So 1.5 minus 2.5 is negative 1. 15 minus 45 is negative 30. And one more time, the b's cancel out. Okay, this time I have a negative times a negative, which makes it a positive when I do the division. So I have 1 over 30 equals m, which of course I'm going to plug back in. So I have my 1.5, which was the first equation here. M I know is 1 over 30. The x was 15, and I have b. 15 over 30 is a half. So I move the 0.5 over to get b by itself, and I just find out that b is equal to 1. So here's my price, 1 over 30x plus 1. All right, so a different thing is happening on supply. This slope is positive, showing that they want to make more money, so it's going up, where the slope was negative for demand, so it was going down. Okay, domain. So let's go back to our function, 1 over 30x plus 1. Okay, again, the smallest x can be a 0, right? I can't have a situation where I have less than 0 products. I could get into situations where there's information given in the problem that may make that making 0 impossible. Maybe we have a contract that says, hey, we have to make at least 5 million or something. But in this scenario, we're saying, well, we could do nothing. We can make nothing. That'd be fine. So it would start at 0. But there's nothing that restricts the rest of it, right? There's nothing that says this will never be 0. There is no cap of what this would go up to. They'd probably be willing to make a ton of these energy drinks if they could just make more and more money. So my domain goes to infinity. How realistic is that? Not really, right? At some point, producers would have to make another plant, hire some more people, so they would have to restructure their price that they're looking for there. But we're just going to go with it and make it easy, say 0 to infinity. The range is going to feel kind of similar because, again, the smallest the price could be would be 0. But there's no max on what the price could be. It could go to technically infinity, but that's really completely unrealistic. No one's paying $1 million for an energy drink. They're not paying $1,000 or $100, but we're just going to let it go 0 to infinity to say there's no restriction that would make it anything else. Okay, so once we know supply and demand, let's talk about market equilibrium. So we want to find the price that drinks should be sold to attain market equilibrium, and then how many cans they'll be able to sell. So first, let's say, well, what is market equilibrium? Market equilibrium is when supply is equal to demand. So both things are happy, they're equal. The amount being supplied is equal to the amount being demanded, so there's no leftovers, right? If we have too much supply, it's left on the shelves. If we don't have enough supply, there's people not getting what they want, and that means suppliers aren't making as much money as they can. It's very theoretical, I'll give you that, how do we know what happens? But for our purposes, we're going to go look at this perfect situation where we got it spot on and we have our supply equal to our demand. So in our case, we take our two equations, 1 over 30x plus 1 and negative 1 over 20x plus 6, and we set them equal to each other. I'm kind of doing this like in a lazy way so you can see all the steps. I put 1 over 30x plus 1 over 20x. So I just brought that negative 1 over 20. When it came to the left, it became positive, and I brought the 1 to the right, and so 6 minus 1 was 5. So I didn't do anything with the fractions yet. Common denominator of 30 and 20, 60 would work, which would give me 5 on top. I know you can reduce that, and I didn't, because when I flip it over, the 5s would cancel, and I would get x is 60. Whatever trickery you want to do on your calculators is awesome. You can use the fraction button on it to be able to get to this point. All right, so with this x is the number of cans to sell. So the answer, this is the answer to the next question, right? It's not the answer to the question we're asking. So this market equilibrium where we solve for x is 60, we know we're not going to pay $60 a can, right? So don't get confused with what we're answering here. We're still answering for the price. Price is P, so I need to go back and plug that in. I chose to put it into the 1 over 30x plus 1. You could also put it into the negative 1 over 20x plus 6. Because they're equilibrium, they will give you the same answer. So I have 1 over 30 times my x, which is 60, and then I add 1. 1 over 30 times 60 is 2. 2 and 1 is 3. So the price that we're going to sell these drinks for is $3 a piece. And then how many cans will we be able to sell? That answer is 60. That's where that x was. So x represents how many cans we can sell. The price of 3 tells me how much they're going to sell for a piece.